Hi everyone and welcome to Specialist Maths. So today we're going to do a little recap of surds. So let's get started. A few definitions first. So we know that a quadratic surd is a number of the form square root of a where a is a rational number. So just remembering what that term rational means, it means something that can be written in a fraction, so something of the form n over n. So for example, the number 10 is rational because it can be written in the form 10 over 1, or 2/3 is rational. And a quadratic surd is where this rational number is not a perfect square. That's because if we had something like square root of 9, we know that can simplify to give 3, so that is not considered a surd. So we've got some properties of square roots. I'm just going to change colour, something a bit better. So properties of square roots: square root of AB equals square root of A times square root of B. So that means if I had square root of 20, that's going to be the same as the square root of 4 times the square root of 5, which we could write as square root of 4 square root of 5. And same here, if we have a fraction, we can split it into the numerator and the denominator. So let's have a look at some examples. Now hopefully a lot of this is familiar to you from year 10. So to simplify square root of 75, I need to look for a perfect square that can be multiplied by something to get 75. So our list of perfect squares, we have 1, 4, 9, so 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 100 squared. I can keep going, but I'm looking for one of these that I can multiply by something to get 75. So in this case, I would have 25 times 3. Our rule we just saw before says that I can split that up into 2 parts. And we know that the square root of 25 is equal to 5. So I get 5 square root of 3. We can do the same thing to simplify here in this second example. Square root of 99, I want to break that into 2 parts. So square root of 9 times square root of 11, which will give us square root of 9 is 3, square root of 11. In the denominator, square root of 64 is the same as 8, so it's going to be over 8. Our third example here, square root of 50 minus square root of 27 plus 45 minus 2 square root of 18. 50, I will again have 25 times 2 in this case, so I'm going to have 5 square root of 2 minus 27, a perfect square to multiply to get 27, we would have 9 times 3. So that will be 3 square root of 3 plus 45, that's 9 times 5. So I've got 3 square root of 5. And here 18 is 9 times 2. So I have the 2 out the front times square root of 9 is 3. And square root of 2 will be under the surd sign there. So I can simplify that last term. 2 times 3 is 6. Looking to see if we can simplify now. We want to see if there are any like terms, and we have here 2 terms that have that square root of 2. So for terms to be considered like terms, in this case, they need to have the same number under the surd sign. So 5 square root of 2 minus 6 square root of 2 is negative square root of 2. The other terms are not like, as they have different numbers under our surd sign, so we have to leave them as they are. If I was putting this in my CAS calculator, I would be in my main menu here, and I want to make sure that I'm in standard mode down the bottom. You can type in whatever it is, as we see there, 50 minus square root of 27 plus square root of 45 minus 2 square root of 18. Oops, I forgot the square root sign. Square root of 18. And if we press equals, it will simplify it for us without needing to do anything else. As you can see, the order is slightly different, but the terms remain the same. Moving on. Another thing we might be asked to do is to rationalise the denominator. So rational numbers are not surds. So rational numbers are whole numbers, fractions, but not surds, which are considered irrational numbers. So that means I need to get rid of the square root of 5 in the denominator. The easiest way to do that is to multiply by square root of 5, because we know square root of 5 times square root of 5 gives us 5. But in order for this fraction to remain equivalent, whatever we do to the denominator, we need to do to the numerator. So this will give us a numerator of 2 times the square root of 5, and a denominator, we have the 3 up the front here, times square root of 5 times square root of 5 is just 5, and we can simplify that because 3 times 5 is 15. Okay, rationalising the denominator in the second case is a little bit trickier, because here, if I was to just multiply by square root of 3 here, what I would end up getting, I need to multiply this entire denominator by square root of 3. So that means I'm multiplying it by both terms. So I would end up with square root of 3 times square root of 3 is 3. Square root of 3 times negative 8 is negative 8 square root of 3. So I still haven't rationalised the denominator. That's not actually working. So we need to do something else instead. And what we do is we multiply by something called the conjugate. So I'm multiplying by the conjugate. And the conjugate is when I change the sign in the middle here. So the conjugate in this case is square root of 3 plus 8. And just off to the side here, I'm going to show you what happens when I multiply square root of 3 minus 8 by its conjugate. So if we're using FOIL, if we're multiplying first terms together, square root of 3 times square root of 3 is 3. Square root of 3, our outside term, square root of 3 times 8 is plus 8 square root of 3. Inside terms, negative 8 times negative 3 is negative 8 square root of 3. And last terms, negative 8 times 8 is negative 64. What happens is that those middle ones disappear and I'm left with negative 61. Hopefully, some of you might have recognised that's because setting up these two brackets is difference of two squares. I've got the same term at the start of both, the same term at the end, a minus in one and a plus in the other. So this means that what I will do is I will just square the first part. Square root of 3 squared gives me 3. Square the last part, 8 squared gives me 64, and a minus sign in between. And this will work every time to get rid of the square root. So when I want to rationalise the denominator here, I multiply by the conjugate. But whatever I do to the denominator, I need to do to the numerator. So when we're looking at this here, in the numerator, 1 times all of this is just going to give us square root of 3 plus 8. In the denominator, when I'm multiplying in this way, as we saw over here, difference of two squares works out and I get negative 61. If we're looking at how we do this in our CAS, so if we've got 1 over square root of 3 minus 8, now I think if we just press enter, it doesn't do very much for us. If we highlight and say interactive transformation simplify, now it's been rationalised. Here we've got the negative in the numerator rather than the denominator, but you can see that it's still the same expression. On to our last set of examples, and it's quite common in BCE maths for a question to ask you to express something in a particular form. So it needs to be written in this way, two terms, one that's just a rational number on its own, one that has a surd. At the moment, I've divided these two. I've got a division going on here, or a fraction. What I need to do to be able to write it in this form, where A, B, and C are all rational numbers. So A, B, C are all elements of our rational set, which you might remember we write with a Q. So that means they can all be written in the fractional form. So to rationalise, I need to make sure the bottom does not contain a surd. So I have to multiply by the conjugate, which is when I have the same two terms and the opposite sign, a plus here, so I will put a minus in here. Whatever I do to the denominator, I need to do to the numerator. Further explaining what we're doing here, 6 times 6 gives me 36. Square root of 5 times square root of 5 gives me minus 5. In the numerator, now this is actually a perfect square when I multiply this. So I square the first term. To get the middle term, I have minus 2 times 6 times square root of 5 plus square root of 5 squared is 5. 36 plus 5 is 41 minus 12 square root of 5 over 31. It's still not quite in this form because that has the A and B terms separately. I need two separate terms. So I just separate out my fraction, 41 over 31, so that's the value of A, minus 12 over 31, that's the value of B, square root of 5, and that's the value of C. The last one here, if I'm expanding this, I again use FOIL. Square root of 7 times 2 is 2 square root of 7. Outside terms, square root of 7 times negative 4 square root of 5. It's going to be negative 4. I multiply what's under the surd sign. 7 times 5 is 35. Inside, negative 2 times 2 is negative 4, and I have a square root of 3. And last terms, negative 2 times negative 4 is plus 8. Square root of 3 times 5 is 15. We do look, can we simplify any of those? No, we can't. This is actually a bad example of mine, I'm sorry. It can't be written in that form. Can't be written in the form that we wanted there. So this is my mistake. When they ask you to write something in that form, usually you'll actually be able to. So for this one, that's as simplified as we get. So my apologies about that. So that's all we have for surds. Now it's your turn to try some of these, attempting exercise 2D. And if you have any questions, make sure that you let me know. So thank you for watching and listening.